you remember we talked about that in the troposphere, the temperature decreases as we go up toward the tropopause. And because the air masses are warmer near the surface, uh, their density is lower than the density of the cooler layers from above. And in that way, there is a continuous mixing or self-cleaning of the lower troposphere where we have the emissions. So now the nights sometimes during the winter, especially in high altitudes, uh, the ground can become very cold, like when we have snow or when it's winter. And in that case, the air near the ground is very cold, and then the temperature increases as you go higher, and then again the temperature decreases, and you see there the night. So now what happens when you have cooler masses and warmer masses relatively above? You remember we talked about we have two liquids, and one has high density and the other has lower density. The liquid with a higher density, it will go to the bottom, right? Like olive oil and water. The water will go to the bottom. So in this case, the same thing happens. The air masses which are cold, they stay in the ground and they have no reason to go above. And in that case, the mixing of the near ground air, it is non-existent, or very slow. And as a result, you have an accumulation of emissions. So this is called the height below which we have a positive lapse of the temperature is called the inversion layer. So inversion layer is the area where the cold air is near the ground and is stagnated, and it does not really go up. And so when we have a low inversion layer, it means that we have high pollution. Okay, so, and this is actually some cases like if we have a mountain and in the top, or a valley, and then unfortunately I'm not there, but if you have a situation like you have two mountains and a valley in the middle, and you have cold surface, there is an inversion layer, and there is no reason there to go over the mountains and ventilate. Like this happens, for instance, in Santiago, Chile, where they have the Andes, the high mountains. And in that case, the air stays days after day and accumulates and becomes more polluted. And this is actually where you have emissions. And here is the boundary layer, the inversion layer, and the emissions do not really mix to go up. So they stay and they accumulate. So this is what we call inversion layer. So that's the end